welcome to Vari Medical Academy. So, உங்களுக்கு எல்லாத்துக்கும் ஒரு குட் நியூஸ். வாரி மெடிக்கல் அகாடமி சார்பாக இனிவரும் நாட்கள் டெய்லியும் ஒவ்வொரு டாபிக் நம்மளுடைய ஃபேக்கல்டி மெம்பர்ஸ் லைவ் வீடியோ ஸ்ட்ரீம் உங்களுக்கு கொடுக்க போறாங்க. Wish you all the best my dear future doctors. டாபிக் ஏதாவது வந்து கிளாரிட்டி வேணும் அப்படிங்கிற எந்த கண்டென்ட் ஆனாலும் கமெண்ட்ல தெரியப்படுத்துங்க. அதுக்குண்டான சொல்யூஷன் வாரி மெடிக்கல் அகாடமி சார்பாக கொடுக்க ரெடியா இருக்கும். இந்த மாதிரி வீடியோக்கள் உங்களுக்கு பிடிச்சிருந்தா மறக்காம லைக் பண்ணுங்க, சப்ஸ்கிரைப் பண்ணிக்கோங்க, உங்க ஃப்ரெண்ட்ஸ்க்கும் ஷேர் பண்ணுங்க, அவங்களுக்கு யூஸ்ஃபுல்லா இருக்கும். Thank you.
Hi, good evening students. In my first video explain about chemical bonding, and the second one is the chemical bonding 2. Chemical bonding. In first video I explained how the atoms are why involved in bonding and octet rule, and two types of bonding, interatomic bonding and intermolecular bonding I discussed. Now today first one, ionic bond. Ionic bond. How to form the ionic bond means transfer of electrons from one atom to another atom to form oppositely charged ions. That oppositely charged ions means the electrostatic force of attraction between two oppositely charged ions are formed due to transfer of electrons from one atom to another atom. That is called ionic bond. Now ionic bond example I am taking NaCl and magnesium chloride, MgCl2. These are the examples. Magnesium oxide are the example of ionic bond. Now Na is gives one electron, Na plus electron. Here is sodium is removing one electron to attain nearest noble gas configuration. That is atomic number is 11. That's why 2, 8, 1. One electron is removing means to attain 8 electronic configuration in outermost orbit. That is neon electronic configuration. Now chlorine, the chlorine taking one electron, 2, 8, 7. It accept one electron to form nearest noble gas configuration, that is 2, 8, 8. Nearest noble gas configuration means that is argon. Now NaCl, how to formed Na plus in gaseous state and Cl minus in gaseous state to form NaCl solid. NaCl solid is formed. Now write the Lewis dot structure. Lewis dot structure of NaCl. If NaCl I am taking Na plus 1 electron. Here is chlorine 1, 2, 3, 4, 5, 6, 7. One extra electron is accepting this one. This is the Lewis dot structure. Another one also there, Na plus and Cl minus 1, 2, 3, 4, 5, 6 and 7. Here is the electrostatic force of attraction between two oppositely charged ions are formed by transfer of electrons from one atom to another atom. That is called ionic bond. Now what are the properties of ionic bond? Now what are the properties of ionic bond means first one is the physical state. In physical state actually it in solid form, NaCl in solid form. In solid state there is a lot of force of attraction between Na plus and Cl minus. This is very stronger bond, but it is act as act as bad conductor. It act as bad conductor. Now properties, first property is physical state. In molten state or aqueous state, it act as conductor. Because whenever dissolving NaCl, two oppositely charged ions are formed, Na plus and Cl minus. Now another property, it is having high melting point and boiling point. High melting and boiling point. Next one, ionic compounds shows isomorphism. They are not showing ionic compounds not showing isomerism. What are the properties? It is having high melting point, boiling point. Ionic compound shows isomerism. Ionic compounds isomorphism. Isomorphism means similar structure, similar size. And ionic compounds not showing isomerism. It is having high hydration energy and solubility. These are the properties of ionic compound. What are the properties? First one is the physical state. In solid state, NaCl, there is a strong bonding is present, that's why it is act as a bad conductor. In molten state, it act as a conductor. And high melting point, boiling point, ionic compound shows isomorphism. For example, NaCl, magnesium chloride, they are similar size. Based on similar size, they are showing isomorphism. Ionic compounds not showing isomerism. This is the isomorphism, this is isomerism. And high hydration energy and high solubility. These are the properties of ionic compound. Next one we discuss lattice energy. What is lattice energy? Lattice energy means 1 mole of ionic compound formed from gaseous cation, gaseous anion. Why we can take lattice energy. What is lattice energy? What is lattice energy means 1 mole of ionic compound, the amount of energy released to form 1 mole of ionic compound, 1 mole of ionic compound from gaseous cation and anion. That is called lattice energy. What is lattice energy? The amount of energy released to form 1 mole of ionic compound from gaseous cation and gaseous anion. Both are anion, cation and anion. Now I am taking NaCl. Now lattice energy directly we cannot determine. By using Born-Haber cycle. Even Born-Haber cycle also indirectly determined. Now Born-Haber cycle, I am taking NaCl, Na plus cation in the gaseous and Cl minus in gaseous state to form NaCl. This energy delta H is equal to negative energy released. 1 mole of ionic compound formed from gaseous cation, gaseous anion. That releasing energy is called as lattice energy. Now lattice energy cannot determine directly by using Born-Haber cycle. Now I am taking heat of hydration or enthalpy heat of hydration, not enthalpy, okay, sorry, enthalpy of formation or heat of formation. Heat of formation. In heat of formation, we can write what is heat of formation? 1 mole of ionic compound, 1 mole of ionic compound formed from 1 mole of ionic compound formed from natural or elemental state or standard state. That amount of energy released called heat of formation. For example, sodium in solid form plus chlorine of Cl2 in gaseous form to form NaCl. Now releasing energy is called heat of formation or enthalpy of formation. Now here also delta H is equal to negative. In both the cases we can write lattice energy. First one, amount of energy released to form 1 mole of ionic compound from gaseous cation anion, that is called lattice energy. Heat of formation means 1 mole of ionic compound formed from natural or elemental state. The elements are we can take in natural, and sodium in solid form, it is a gaseous form to form NaCl. This energy is called as heat of formation. This energy is called as lattice energy. Enthalpy of formation. What is enthalpy of formation? 1 mole of ionic compound formed from its natural or standard state. The amount of energy released is called enthalpy of formation. For example, Na in solid state, it is naturally available standard state of Cl2 gives rise to NaCl. The releasing energy is called delta H is equal to negative. This is the energy when 1 mole of ionic compound formed from its natural or elemental state, that is called enthalpy of formation. Now we can take this amount of is enthalpy of formation. Now I am taking Na is converted to solid, is converted to gas. What is the energy? That is called sublimation energy. What is sublimation energy? Sublimation energy means solid is converted to gas, that is called sublimation energy. We can write Se. Now the gaseous ion is isolated ion. This is a gaseous isolated ion. Now isolated condition only we can remove the electrons. What is the removing of electrons? Removing of electrons is called as ionization energy. What is ionization energy? The amount of energy required to remove the valency electron of isolated neutral gaseous ion, that is called ionization energy. Now it is formed Na plus ion, that is a gas. Now I am taking sodium is a solid form. Now sublimation energy, then solid is converted to gas, that is called sublimation energy. Now sodium is a gaseous atom, isolated atom. Now amount of energy we can remove the electron, valency electron, that is Na plus cation is formed. Now here is chlorine is there, that is bond dissociation energy. Now write dissociation energy by 2. Now it is formed Cl, that is a gas. Now I am taking electron affinity. What is electron affinity? The amount of energy released, the extra electron added to the outermost shell of isolated gaseous neutral atom, that is called electron affinity, to form Cl minus. This is also gaseous anion. Now it is the gaseous cation, gaseous anion. These two are mixing, these two are reacting to form, that energy is lattice energy. That is called lattice energy. Now you taking direct from solid elemental state, that is called enthalpy of formation. This is equal to this all steps. Now write what is the energy, we can write it. Now first sublimation energy plus next ionization energy plus we can take dissociation energy by 2 and minus electron affinity minus lattice energy, that is called delta H. This energy is equal to this process. Now what is, first I am taking enthalpy of formation, another one is the lattice energy. What are the steps? These steps, energy released is equal to the direct step solid and this is the elemental state, that are equal. We can calculate from Born-Haber cycle. Now another one is the lattice energy. Lattice energy is directly proportional to charge on cation and anion. Lattice energy is directly proportional to charge on cation, anion, and lattice energy inversely proportional to size. When size increases means lattice energy decreases. Lattice energy increases means when charge increases means lattice energy increases. For example, I am taking Na plus and magnesium plus 2. Next to Al plus 3. Which one is the more lattice energy? We can take Na plus, magnesium plus, Al plus 3. Al plus 3 is the more charge, that's why more lattice energy. We can take lithium, sodium and potassium, rubidium and cesium. Here is size is from top to bottom, size is increases. When size is increases means which one is the more lattice energy? Lithium is the more lattice energy and cesium is the less lattice energy. Another one also we can take lattice energy directly proportional to force. What is the force formula? Force is equal to K Q1 Q2 by R square. Now the distance between, what is the bond length? The distance, half of the distance between two atoms, that is called as bond length. When bond length increases means when radius increases and bond length also increases. When bond length increases means the force is decreases. Now lattice energy decreases. Lattice energy also decreases. These are the, we can define the enthalpy of formation. Another one is the lattice energy. What is the enthalpy of formation? The amount of energy released to form 1 mole of ionic compound formed from elemental or natural or a standard state, that is called enthalpy of formation. And what is lattice energy? The 1 mole of ionic compound formed from gaseous cation, gaseous anion, the amount of energy released equal to, that is called lattice energy. These are the enthalpy of formation and Born-Haber cycle completed. Next one we discussed Lewis dot structures. Lewis dot structure, the very important in chemical bonding. And if one question last time 2021, one question asking BF3 how many electrons are present and what is the hybridization. I am taking BF3. Now this is the BF3. BF3. Surrounding boron, how many electrons? 6 electrons are present. This is electron deficient. It is not follow octet rule. It is not follow octet rule. And next one is, what is hybridization? Hybridization formula, you know, of that is total number of valency electron, this boron atom. The boron atom is belongs to third group, that's why 3 electrons are present, valency electron. 3 plus number of monovalent atoms 3. There is no positive charge, there is no negative charge. Now we can take 3 plus 3, 6. 6 by 2 means 3. sp2 hybridization. sp2 hybridization, trigonal planar geometry. Trigonal planar geometry. Now we will discuss Lewis dot structure, the very, very important topic. We will erase this one. Lewis dot structure. Lewis is the scientist explain this Lewis dot structures. Lewis dot structures. What are the rules for? Here is, whenever Lewis dot structure, first one is the outermost electrons, that is called. Another one is the valency electrons. Every atom must satisfy octet rule, means every atom must contain 8 electrons in outermost orbit. That is, outermost electrons means valency electrons. It can be explain the structure. Another one is the, in Lewis dot structure, every atom must follow octet rule. Every atom must follow octet rule. Another one is the, what is the central atom not follow octet rule. This is the neglect. Central atom is not follow the octet rule, means 8 electrons are more than 8 electrons. These are the Lewis dot structure explain the outermost electrons are valency electrons, and octet rule, every atom must contain 8 electrons in outermost orbit, but the central atom do not follow octet rule. What are the selecting rules for selecting rules for central atom? What are the selecting rules for central atom? Now we can take selecting rules. First one we can take least number, then least electronegativity atom. Another one is the large size. The size is large, that is taking as central atom. Another one is the hydrogen and fluorine. They never act as central atom, because hydrogen and fluorine, they never act as central atom. And first one is the least electronegativity and larger size. Another one, they are mentioned oxygen showing 2,4 covalency, sulfur 2,4,6 covalency, nitrogen showing 3,5, and phosphorus also 3,5, and carbon showing 4 covalency. Number of bonds here, I think 1 to 2 only. Oxygen is 1 to 2, sulfur is 2,4,6, nitrogen 3,5, phosphorus also 3,5, chlorine is showing 1, 3, 5, 7. These are the covalencies are showing. Next one is, if central atom not follow not follow octet rule. They are not following octet rule. Okay. If positive charge is present, if positive charge is present, where it is present in positive charge? It is positive charge is present on central atom. Yes, central atom contain positive charge. For example, I am taking He3O plus. Where is the positive charge? Oxygen having. If you taking NH4 plus, where is having? N. This is the, if positive charge is present, it is present on central atom. If negative charge is present, negative charge is present on corner atoms. Corner atoms. These are the selecting rules for central atom. If negative charge is present on corner atoms and positive charge is present on central atom not follows octet rule. These are the rules of Lewis dot structure. Next one is corner atoms must follow octet rule. But central atom it is follows or not, it's not a problem. But corner atoms must follow octet rule. Now these are the selecting rules of central atom while you are writing Lewis dot structures. Least number, least electronegativity, larger size. Hydrogen and fluorine, they never act as central atom. Oxygen is showing 1, 2 covalency, sulfur 2, 4, 6. Here is nitrogen is 5 means 3 bonds, 2 lone pairs. Phosphorus also 3, 5. Carbon 4 and chlorine 1, 3, 5, 7. Central atom not follow octet rule. It's not a problem. Central atom it's 8 electrons, more than 8 electrons. But positive charge, where it is present positive charge? Central atom. Here positive charge present, central atom. Where is the central atom? Nitrogen. Here negative charge is present on corner atoms. And next one is the corner atom must follow the octet rule. These are the rules of Lewis dot structures. Now I am writing one formula, very important. Q is equal to total number of valency electrons plus negative charge minus positive charge. Please remember these formulas, it's very very important. And the Q is equal to total number of valency electrons plus negative charge minus positive charge. Another one is these are the Q. Q means total number of valency electrons. Next one is bond pairs, number of bond pair of electrons. Number of bond pair of electrons is equal to 2 into number of bonds. Now I am taking lone pairs. Lone pair of electrons is equal to Q minus BP. Bond pair of electrons. This one, what is the Q? Total number of valency electrons. Bond pairs means 2 into number of bonds. And please remember this, it's very very important while you are writing a Lewis dot structure. These are the selecting rules after. We can take a total number of valency electrons, negative charge, positive charge, and bond pair of electrons means 2 into number of bonds. Lone pairs is equal to Q minus bond pair of electrons. These are the, we can take one by one example, we can solve the Lewis dot structure. Shall I erase it? And next, I am taking one molecule, I am write the Lewis dot structures. It's a very very important while you are writing Lewis dot structures. Okay, now I am taking hydrogen. First one I am taking hydrogen, H2 I am taking. Now Q is equal to, what is the Q? Q is equal to total number of valency electrons, that is 2 electrons. Yes or no? because hydrogen is like this, na? 2 hydrogens means 2 electrons. Now bond pair of electrons is equal to, I am taking here a hydrogen, here also hydrogen, I am taking one bond, this is the one bond, na? One bond. Now 2 into number of bonds, 2 into number of bonds means 2 only. Now bond pair of electrons is equal to 2. Now lone pairs is equal to Q minus Bp, bond pair of electrons. Now I am writing 2 minus 2, that is 0. 0 lone pairs. We can denote it as hydrogen means here is 1 and here also 1. This is the Lewis dot structure. If you write this one also, it is correct. Lewis dot structure. I am taking another example. Which one example we can take? O2. O2 is a very easy, na? O2. Now, how many valency electrons are present? And oxygen is which group it belongs to? It is 16th group, 6th group elements. Oxygen, sulfur, selenium, tellurium, polonium. Now, total number of valency electrons, how many oxygen atoms are present? 2 oxygen atom, 2 into 6, that is equal to 12 electrons. Total 12 electrons, that is equal to Q. Now, bond pairs of electrons is equal to, you can count it, bond pair of electrons. Oxygen I am taking here, another oxygen I am taking here. I am taking one bond, just this one is the oxygen and this one also oxygen. I am taking one bond. Now bond pair of electrons, how many? Bond pair of electrons is equal to 2 into number of bonds, that is one bond only. Now that is equal to 2 electrons. Now lone pair of electrons, what is the formula? Q minus Bp, bond pair of electrons, that is equal to 12 minus 2, that is equal to 10 electrons. 10 electrons. Now I am writing 10 electrons means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I am thinking this is how many this satisfy octet rule or not? 1, 2, 3, 4, 5, 6. No, not satisfying. Here is 1, 2, 3, 4, 5, 6, 7, 8. But this atom is satisfying. Now what I have to do? This one I release and I am writing like this. The structure of the Lewis dot structure oxygen, I am writing like this: oxygen, 2 double bond oxygen, here one lone pair, here one lone pair, here one lone pair, here one lone pair. This is the Lewis dot structure of oxygen. If you take a number of example one by one, we can take NH4 plus. NH4 plus. Where is the positive charge is present? The positive charge is present only nitrogen atom, not hydrogen atom. Because hydrogen atom is the corner atoms. Okay, na? Now I am taking Q is equal to, what do you know? Total number of valency electrons. What is the nitrogen group number? 5th group. Nitrogen, phosphorus, arsenic, antimony, bismuth. Now total, what is the electronic configuration of nitrogen? 1s2, 2s2, next to 2p, 3. 3, 2, 5, 6, 7. The atomic number is 7. S. How many valency electrons? Outermost electrons. These are the outermost electrons. 2s2, 2p3. Now I am taking how many nitrogens are present? 1 nitrogen. That's why I am taking 5 plus. How many hydrogens are there? 4 hydrogens. Yes. Now negative charge is there and positive charge is there. Positive charge. Positive charge means minus. Just you can take minus. Now I am taking Q is equal to 5 plus 4 is 9. 9 minus 1 is equal to 8. 8. Q is equal to 8. Now I am taking this is a structure. Just I am writing how many hydrogens? 1 hydrogen. I am writing here. Here 1 hydrogen. Here 1 hydrogen. Here 1 hydrogen. How many hydrogens are there? 4 hydrogens. 1, 2, 3, 4 hydrogens. Now number of bonds, tell me. 1, 2, 3, 4. 4. Now bond pair of electrons is equal to how many? 2 into 4. What is the number? 8. Now lone pairs is equal to, what is the formula? Q minus Bp. 8 minus 8, that is 0. There is no formula. Now plus is there, sir. Where I present that plus? Now central atom is contain positive charge. That's it, the structure of NH4 plus. Next I am taking the big molecules that are SO4 2 minus, PO4 3 minus, CO3 2 minus, One by one we can discuss. Next, here is positive charge is present. Where it is present? Central atom. Corner atoms satisfy the octet rule. No. Hydrogen is the duplet. Duplet they satisfy, and remaining is the octet. Nitrogen is satisfying or not? 1, 2, 3, 4, 5, 6, 7, 8. This is the Lewis dot structure of NH4 plus. Next, coming to, we can explain H3O plus. H3O plus. Next one is SO4 2 minus. Next one is PO4 3 minus. Next one CO3 2 minus. Next one NO2 minus 1. These are the example, number of example we can write it. H3O plus I am counting now. Q is equal to, what is the name? Q means total number of valency electrons plus negative charge minus positive charge. Now Q is equal to central atom 6 plus how many hydrogen atoms? 3 hydrogen atoms minus, that is charge is 1, that is equal to 6 plus 3, 9 minus 1, that is equal to 8. Now I am taking oxygen is the central atom. Yes, central atom. How many hydrogens? 3 hydrogens. Oh, hydrogen, 3 hydrogens. Very nice, duplet. Now where is the oxygen? Oxygen, this one. Where is the positive charge is present? Now I write the positive charge here. Okay. Now we can take a bond pair of electrons, count it. How many bond pairs? Here is 1, 2, 3. 3 to ja 6. 2 into number of bonds. 2 into number of bonds. 1, 2, 3. That is the 6 electrons. Yes. Now Q minus BP, bond pair of electrons, lone pair of electrons is equal to Q minus BP. That is equal to 8 minus 6, that is equal to 2. Where is the lone pair is present? Yes, lone pair is present here only. Lone pair. Yes. Where is the positive charge? Here only positive charge. This is the structure of H3O plus. If you take NO2 minus, I am taking. NO2 minus is a very interesting. NO2 minus. Yes, NO2 minus 1. Now nitrogen, Q is equal to, nitrogen belongs to fifth group. 5 valency electrons. Yes. And 2 into 6. Why 6? This one is a 6th group, 16th group plus 1. Why plus 1? Because minus charge is there. That's why you can write the plus. Then Q is equal to 5 plus 2 6 are 12. 12 plus 1, that is equal to 18. 18 electrons. 18 electrons are present. Now I am writing nitrogen, structure of nitrogen. How many nitrogens are there? 1 nitrogen here, and here is also another nitrogen is present. Where is the NO2 minus? NO2 minus. Where is the NO2 minus? You can out to, this is the bond pair of electrons 1 and 2. Bond pair of electrons is equal to 2 into number of bonds. Number of bonds means 2. That is equal to 4 electrons. Now write ma, lone pair of electrons is equal to 18 minus 4. That is equal to 14 electrons are present. Where it is present 14 electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 13, 14. 14 completed. Now, one doubt, sir, where is the minus charge is present? Minus charge is the corner atoms. Yes, corner atoms minus. Now, this one is following octet rule. 1, 2, 3, 4, 5, 6, 7, 8. Yes, it is follows. 1, 2, 3, 4, 5, 6. Now I am writing, remove this lone pair. 2 lone pairs are present. Na? Lone pair is present. Here is double bond is present. Now I am taking, here is a positive charge. Why positive charge, sir? I will explain why positive charge. Here is positive charge. Here is negative charge. Okay. Now, why negative it is present? Negative, here is positive. Now I am checking formal charge. What is formal charge? Total number of valency electrons minus lone pair of electrons minus bond pair of electrons by 2. bond pair of electrons by 2. Now I am taking formal charge of this one, I am taking 1, this one I am taking 2, this one I am taking 3. Okay, now first one I am taking oxygen. Oxygen means how many valency electrons? The first one valency electrons is 6 minus. Next lone pair of electrons how many? 1 2 3 4. Yes, 4. Bond pairs how many bonds? 1 2 2 2 ja 4, 4 by 2, that is equal to 2 2. That is formal charge is 0. First structure formal charge is 0, this one. Next I am taking this one, nitrogen. If you take nitrogen of formal charge of nitrogen second structure, now valency electrons 5 minus lone pairs 2 minus how many bond pairs? 1 2 3, 3 2 ja 6, 6 by 2, 2 3. Now here also 5 2 means here also 0. There is no positive charge. There is no positive. If positive charge is coming, yes, 2 3 5 5 5 0. No? Formal charge is 0. Now I am checking this third one. If checking third one, formal charge of third one, oxygen is 6 minus how many lone pairs? 1 2 3 4 5 6, 6 minus if you take how many bond pairs? 2 by 2, that is equal to 1. Minus 1 is present. Yes, minus 1 is present, but here is no positive charge. Okay, now initially I am writing positive charge. While checking the formal charge, it is not present. That's why I am writing there is no positive charge. These are the structures. If you take a PO4, SO4 2 minus, SO4 2 minus, understand this one. Actually I am right firstly plus, but after I am checking formal charge, there is no charge, only lone pair is present, no positive charge. Now I am taking SO4 2 minus, SO4 2 minus and CO3 2 minus. Now I am taking SO4 2 minus, first one I am taking SO4 2 minus. Now Q is equal to total number of valency electrons sulfur 6, and next one is 6 4 ja plus 2, that is equal to 6 plus 24 plus 2, that is equal to 24 plus 6 30, 30 plus 2 32. That is the Q value. Now I am taking sulfur, one oxygen atom. I don't know where is the negative positive, but I am writing the structure like 4 bonds. Now bond pair of electrons is equal to 2 into number of bonds. Number of bonds is 4, that is equal to 8 electrons. 32 minus 8 means we can take a 24. Yes or no? 24 electrons. 24 electrons. Now write 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24. Completed 24. Now where is the lone pair of electrons? Means 24 I am writing like this. But where is the charge? 2 minus means I am just remove this. Here double bond. Here also I am writing double bond. This one I have removed. Here is minus charge. Here also minus charge. If check the formal charge, this one is the 1, this one is the 2, and this is the 3. Yes or no? 4. This one is the 5. If sulfur is having any positive charge or not. Now what is the formal charge formula? Formal charge formula is equal to V minus lone pair minus bond pairs by 2. Okay. Now valency electrons tell me sulfur. If you take first and I am taking first and second structure. Valency electrons 2 are same na? Oxygen means 6 minus. Now how many lone pairs? 1 2 3 4 5 6. Now bond pairs tell me 2 by 2, that is equal to minus 1. We can take minus 1 only na? Minus 1 means that first and second structure having minus 1 charge. Next, check the formal charge and third and fourth. If you take third and fourth, what is the valency electrons? 6. Yes. Number of lone pairs 1, 2, 3, 4. 4 minus how many bond pairs? 1 and 2. 2 to ja 4. 4 by 2, that is equal to 2. There is 0. 0 charge. That's why I am writing simply like this. Now check the sulfur. Formal charge of sulfur. Sulfur means fifth one. Na? Now sulfur is equal to 6. Lone pairs is 0. Bond pairs 1, 2, 3, 4, 5, 6. 6 to ja 12. 12 by 2 means 6. That is also 0. This is the structure of SO4 2 minus. If you take CO3 2 minus, also very easy. CO3 2 minus. Now carbon is 4. Why sir 4? That is equal to carbon which belongs to fourth group. Oxygen 6 3 ja plus negative charge is there 2. Now 6 3 ja 18, 20, 24 electrons. Yes. Now I am taking carbon bond, here one bond, here one bond, here one bond. Just I am writing 1, 2, 3. 3 bonds are present means bond pair of electrons is equal to 3 into 2, that is equal to 6 electrons. 24 minus 6 means 18 electrons are present. 18 electrons. Where should I write 18 electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. This one is a Lewis dot structure? No. This is not Lewis dot structure. I am writing satisfied, but it is not correctly. What should I write? Where is the negative charge is present? Corner atoms. I write here is one corner atom, here also minus charge. Now I am taking this remove. Here is 2 lone pairs now. Now double bond is present. Okay. Now I am checking formal charge for this one 1 and 2, and this one is the 3, and this one is the 4th. Now I am checking first one. Formal charge is equal to, what is the formula? V minus lone pairs minus bond pairs by 2. Now I am checking formal charge of 1 and 2. Tell me oxygen. Oxygen is 6. Very easy. Lone pairs 1, 2, 3, 4, 6. Bond pairs 2. 2 by 2 means 1 minus 1. Yes, minus 1, minus 1. Next, checking for this oxygen atom formal charge. Easy only. And carbon, whether it is positive charge or negative charge. If you take a carbon is 4 minus. If you take what is the formal charge is equal to carbon 4 and 0. Now I am taking how many bonds? 1, 2, 3, 4. 4 to ja 8 by 2, that is equal to 4. Now formal charge on carbon 0. This is the Lewis dot structures. If any structure, we can write it by using this formula. What are the formulas? Very, very important. Q is equal to total number of valency electrons. Total number of valency electrons. Valency electrons means outermost electrons plus negative charge. Okay now, plus negative charge minus positive charge. Please remember this one. Bond pair of electrons is equal to 2 into number of bonds. 2 into number of bonds. And lone pairs is equal to Q minus BP. This one is a very, very important, these 3 points. Next, formal charge count, it means valency electrons minus lone pairs minus bond pairs by 2. For this one, you can any structure, you can write the Lewis dot structures. Thank you for listening.